explain the meaning of differentiation and what are the techniques of differentiation in question 1. So what are the meaning of differentiation? Differentiation is the process of finding the derivative of a function. In other words, it can tell us the rate of change or slope of a curve at any point. If a function is y equals to fx, then the derivative of fx are represented with respect to x. For example, f prime x equals to dy over dx. Then, let's move to the techniques of differentiation. There are several techniques of differentiation that we used to know. First of all, we have the power rule. The formula is d over dx, x exponent n equals to nx exponent n minus 1. For example, d over dx, x exponent 4 equals to 4x exponent 3. In this case, we just have to bring the exponent in front and reduce the exponent by 1. Next, we have constant rule. The formula is d over dx, c equals to 0. Constant don't change, so the rate of derivative is equals to 0. Furthermore, we have sum and differences rule. We can divide by two rules, which is sum rule and differences rule. For the sum rule, the formula is d over dx, f multiplied with x plus g multiplied with x. It is also written as d over dx, f multiplied with x plus d over dx, g multiplied with x. Then we have difference rule. The formula is f multiplied with x minus g multiplied with x. The fourth technique is product rule. We use this rule to multiply two functions. If y equals to uv, then dy over dx equals to uv prime plus vu prime. The next technique is quotient rule. It is dividing one function by another. If y equals to u divided by v, then dy over dx equals to vu prime minus uv prime divided by v the power of 2. Chain rule also the technique of differentiation. The formula is f prime x equals to g prime open bracket h multiplied with x close bracket multiplied with h prime x. Then the derivative of trigonometric function also the technique of differentiation. The formula is divided by 3. First one, d over dx sin x equals to cos x. Second, d over dx cos x equals to minus sin x. Third one is d over dx tan x equals to sec the power of 2 x. The last technique of differentiation is derivatives of logarithmic and exponential functions. It only has two formulas, which is d over dx ln x equals to 1 over x and d over dx e the power of x equals to e the power of x. For example, y equals to ln 2x equals to dy over dx 1 over 2x multiplied with 2, then we can get 1 over x. We can simplify by divide 2x with 2, so we can get 1 over x.
Hi everyone, let's solve question 2a and b with me. First of all, we are given that y equals to 3x squared sec x plus 2. Since this equation have one function that multiply with another function, we can use product rule to find the dy over dx. We need to remember the formula of product rule, which is dy over dx uv prime plus vu prime. Then we need to identify which is u and v. As we know, u will be the first part of the function and v will be the second part of the function. Okay, let's identify which is u and u prime. First, we know that u will be 3x because 3x squared is the first part of the function. So, u prime will be 6x. Next, we must know which is the v. We know that the second part of the function is sec x plus 2. So, x plus 2 will be the v. So, we need to derive it. To find v prime, we know that sec x, when we derive sec x, it will be sec x multiplied tan x. So, we derive it and we will get v prime is sec x plus 2 multiplied tan x plus 2. So, we can use product rule to find the dy over dx. We can insert all the u prime, v and v prime into the formula. Then the equation will be dy over dx equal to 3x squared multiply sec x plus 2 tan x plus 2 plus sec x plus 2 multiply 6x. Then we can simplify the equation. The final answer will be 3x squared sec x plus 2 tan x plus 2 plus 6x sec x plus 2. Next, we are given y equals to 4x plus 2 over cos x. This time, we can use quotient rule, which is dy over dx vu prime minus uv prime over v squared. To find the dy over dx for this equation, we need to identify which is u and which is v. As we know, u will be 4x plus 2 and v will be cos x. Then we need to identify the u prime and v prime. As we know, 4x plus 2 is u and cos x will be v. Since 4x plus 2 is u, then the u prime will be 4s and v prime will be negative sine s. Remember, v prime will be negative sine s because u is cos s. The derivation of cos s is negative sine s. Then we can insert u prime, v and v prime into quotient rule to find dy over dx. So the equation will be dy over dx equals to cos x multiply 4 minus 4x plus 2 multiply negative sine x over cos x square. Final answer will be 4 cos x 4x plus 2 sine x over cos x square.
Hi everyone, today I'm going to walk you through on how to solve this question using implicit differentiation. We're given the equation y ln 3x minus e to the power of 2x plus 1 minus tan 4y equal to 0. This equation involves both x and y, and our goal is to find dy over dx, the derivative of y with the respect of x. For the first step, we need to differentiate both sides implicitly. We start by differentiating each term with respect to x, keeping in mind that y is a function of x. So, when we differentiate any term involving y, we apply the chain. Let's start. From the equation, we can identify the u prime, v, and v prime. For u is equal to y, and v is equal to ln 3x. U prime is equal to dy over dx, meanwhile v prime is 1 over 3x multiplied by 3. We can simplify that as 1 over x, e to the power of 2x plus 1. We all know that e to the power of fx multiplied by f prime x. So, from that, we can get e to the power of 2x plus 1 multiplied by 2. Then, we can simplify it as 2e to the power of 2x plus 1. The third term is tangent 4y, which is a chain rule problem. The derivative of tangent 4y will be sec square multiplied by 4y multiplied by 4 dy over dx. Next, for the second step, we need to combine all the terms together, which we will get y multiplied by 1 over x plus ln 3x multiplied by dy over dx minus 2e to the power of 2x plus 1 minus 4 sec square multiplied by 4y multiplied by dy over dx. We will get y over x plus dy over dx ln 3x minus 2e to the power of 2x plus 1 minus 4 sec square 4y dy over dx equal to 0. We solve the equation by moving all of the dy over dx to the left side of the equation. We will get dy over dx ln 3x minus 4 sec square multiplied by 4y multiplied by dy over dx equal to 2e to the power of 2x plus 1 minus y over x. For the last step, we need to rearrange the equation. Then, we will get dy over dx is equal to 2e to the power of 2x plus 1 minus y over x over ln 3x minus 4 sec square multiplied by 4y. Thank you!
Okay, so hi. Now, I want to tell you guys how to solve question 4 for assessment 2. So the question is, use linear approximation to estimate the value of 18.99 square root of 4 minus 2 over 18.99 square root of 2. Correct to 3 decimal places. Okay, so first thing first, how do I solve the question is, I take 18.99 as the value of x. So the value of x in this question is 18.99. So we have to find the value of x not 2 in this question. So I take the number closest to 18 as x naught. So it will be 18.1. Okay, so and then we have to find the equation of fx. So we just substitute the x. We just substitute the 18.99 value with x. So it will be fx equal to x square root of 4 minus 2 over x square root of 2. And then I don't want to leave the equation in the square root, so I raise it to a power number. So it will be fx equal to x to the power of 1 over 4 and then minus with 2x to the power of negative 1 over 2. So that is the equation for fx. And then we have to find the equation of f prime x. So for f prime x, we just differentiate the equation of fx. So when we differentiate, we get 1 over 4 x to the power of 3 to the power of minus to the power of negative 3 over 4 plus with x to the power of negative 3 over 2. And then I take it down the power so that it will become a fragment. So the equation will be f prime x equal to 1 over 4x to the power of 3 over 4 plus with 1 over x to the power of 3 over 2. The last step is we just have to substitute the fx equation and f prime x into the equation that given to us. So the equation is f x naught plus with delta x equal to fx naught plus f prime x multiplied with delta x. So for fx naught, we just have to take the equation of fx, which is
x to the power of 1 over 4 minus with 2x to the power of negative 1 over 2 plus with f prime x naught. So we just have to substitute with the equation of f prime x that we get earlier, which is 1 over 4x to the power of 3 over 4 plus with 1x to the power of 3, which is 1 over 4x to the power of 3 over 4 plus with 1x to the power of 3 over 2, and multiply with delta x. Delta x is x minus 2 x naught. So it will be 18.99 minus 281. So we will get negative 0.01. So we just have to substitute the value of x naught with 18.1. For the last answer, we will get 2.778.